In this lesson, we want to apply the distributive property to multiplying radicals, but really it works the same way. If you have a term outside of the bracket, that term needs to multiply every term inside the brackets. Now, when I look at 6, I know it has prime factors of 2 and 3, and those have no common factors in 5 and 7, which are both prime. So I know I don't need to worry about simplifying here. I can simply multiply. Root 6 times root 5 is root 30, plus root 6 times root 7, root 42. Now, if you're not sure what I was saying, think about the prime factors of 30. There's my 6 times 5, no common factors. Same thing with 42. Again, 6 times 7, no common factors. These are not like radicals. They cannot be combined any further. In the second example, we're multiplying integers and radicals. So we have to use that property we talked about. We multiply the numbers outside of the radical sign. We multiply the numbers inside the radical sign. So when I use the distributive property here, 2 times 3 is 6. 2 times root 6 is simply 2 times root 6. I don't combine them any further than that. Why don't you pause your video and try question 3. Again, we have an integer and a radical. That gives us 3 times the root of 2. And then I'm multiplying 2 radicals. Root 2 times root 5. I can combine those under the same sign. Root 10. And of course, because 2 and 5 are prime numbers, it can't be simplified any further. I want to talk about question 4 with you. Can you see that those radicals would have to be simplified? There's a 3 common in 3 and 6. There's a 3 common in 3 and 15. I could multiply these and get root 18 minus the root of 45 and then prime factor. But I'm going to suggest we should just prime factor. Root 3 times root 6, well, 3 is just 3, and 6, that's 3 times 2, minus root 3, there's my 3, 15, 3 times 5. So you could multiply them and get 18 and 45 and then prime factor, or you can just go ahead and prime factor. I'll leave that up to you, whatever you find easiest. In the first term, I see 2 factors of 3 that we can take out. And in the second term, we have 2 factors of 3 we can take out. So this simplifies to 3 root 2 minus 3 root 5. These cannot be combined any further. They are not like radicals. It doesn't matter that the coefficients in the front are the same. Look at question 5. The term outside the brackets has an integer and a radical. That means the 4 is going to have to multiply the 1 that we never write in front here, but remember, we're only multiplying integers. So we have 4 times 1, root 6 times root 5, that's root 30. I know there's nothing common there. 6 is 2 times 3. Plus 4 times 1, and then root 6 times root 7, nothing common there either, but you can prime factor if you want to be sure. Let's do one more like that together, and then I'll let you try the next 2. 5 root 2 times root 3. The 5 doesn't have anything else to multiply by. Root 2 times root 3 is root 6. There's a plus sign. 5 times 2, this time there's an integer outside. And then the root 2 times root 11, root 22. Pause your video, try question 7. So 4 root 6 times the 2 root 3, we start with 4 times 2. Root 6 times root 3, I know there's going to be a 3 common there. 6 is 2 times 3, and then I have my root 3. Minus 4 times 1 is 4. Root 6 times root 2, we know there's going to be a 2 common. So I'm going to prime factor 6, and there's my root 2. We see 2 factors of 3 we can take out. 2 factors of 2 we can take out. 3 times 8, 24, root 2. 4 times 2, minus 8, root 3. Pause your video, try question 8. Remember, you're always multiplying the integers by the integers. So we start with 5 root 14 times 3 root 21. 5 times 3 is 15. And I can see that 7 is going to be common in 14 and 21. So let's prime factor. 14 is 2 times 7. 21 is 7 times 3. 5 times negative 2 is negative 10. Let's prime factor 14 and 10 because I see that 2 is going to be common. 14 is 7 times 2. 10 is 2 times 5. There are 2 factors of 7 that can come out. 2 factors of 2 that can come out. Oh, 15 times 7, I think that's 105, leaving the square root of 6. 2 times 10 minus 20 times the square root of 35. You know, when you're learning difficult topics in mathematics, it's often a good idea to go back and do the same questions again. So if you had trouble with this section or any of the previous lectures, go back with a pen and paper and listen and do the questions again. Do them over and over and over. Practice until you cannot get it wrong.